Alright, welcome to this video on triangle congruence. Still talking proof, talking about how to prove triangles congruent, kind of looking at these triangle pictures, what can we assume here, and could they be proven congruent. So for this first one, we've got two angles congruent to two angles. You also have this side congruent to each other by reflexive. So here, this could be proven by angle side angle. Here, we have a little reflexive going on, so I'm going to mark that. So we have this side congruent to this side to this side, and this one to itself. So this one can be proven via side congruence. Here, we have angle, angle, and then a side. Angle, angle, and a side. So we would have AAS congruence. Here, this one's a good one because we have a right triangle and we have side angle, but since it's a right triangle, really what we have is hypotenuse leg, which is enough to prove something congruent. I do also want to say that in reveal, occasionally they'll talk about leg, because obviously if you had leg, you would also have leg hypotenuse. So there are some other ones out there. HL is just kind of what we focus on, but just kind of pay attention to that. All right, the number 5, classic one here. We can mark the vertical angles, but we have side angle. The angle is not between the side. We would need this side marked congruent to this side to be able to say these triangles are congruent. So this one is not congruent. Okay? Not necessarily congruent. They obviously look congruent, but... All right, so we've got parallel lines here with this symbol cut by a transversal. So we would also know that this angle is congruent to this angle. So here we have angle side angle. Okay, we have 7, little reflexive for side angle side. Reflexive on number 8 as well for side. Number 9, got some vertical angles there. So you could go angle side. You could also just go hypotenuse leg. They would both work. They're related and similar. Number 10, we have vertical angles. So we have angle side. Number 11, not enough information. Okay, that side is congruent to that side. We have an angle, but not enough information. And then we got parallel lines. We got vertical angles there. We've got angles here or angles here. So I could see ASA or AAS on this one. All right, let's do a couple of proofs here. All right, again, we don't really know how we're going to prove these. Let's write down the given. L is midpoints of Kn and MP. So let's just do some marking. So if L is the midpoint of Kn, we have this side congruent to here. This side congruent to there. So let's go ahead and write that down. ML congruent to LP. Forgot to write given there. Why? Well, it's midpoint, so we would write definition of midpoint. And then we're going to do it again. So KL congruent to LN, definition of midpoint. Now, as I look at this triangle, the only other thing I can do is talk about vertical angles. So I can go ahead and say that angle MLK congruent to angle PLN by vertical angles. And then I could go ahead and say triangle, send a proof. Wish we had that button here. And we've used side, angle, side. All right, one more here real quick. Actually, two more. Then we'll be done with this video. So BD bisects ABC. So I'm going to just go ahead and say that then this is congruent to that. I'm going to mark that. And then I'm going to mark my, so I'll write that down. BD bisects ABC by given. Then we would have bad angle BAD congruent to angle BCD by given. Let me mark that down. BAC, BCD. So, we also have to, we never actually said, even though we wrote bisects, we got to actually write this down. So, angle ABD congruent to angle CBD by angle bisector theorem. The only other thing we can mark on this triangle is reflexive. So we could go BD congruent to BD by the reflexive property of congruence. And then what we have marked on our triangles, again, send a proof. ABD congruent to CBD. Send a proof, angle, angle, side. All right. Looks like we got like everything just given to us here almost in number 3. So S is the midpoint of QU. I'm going to write down all the givens and then I'll go through. S is midpoint of QU given. Okay, I can't mark anything down yet because I haven't proven anything congruent. QR congruent ST. So QR ST given. RS congruent TU given. Might be the easiest proof we've ever done. RSTU. Now the only other thing we need to do is we need to say that QS is congruent to SU by definition of midpoint. And then we can say the triangles are congruent by triangle STU by the side congruence theorem. All right, well done. Do your Alex, do your reveal, get after it.